أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. I welcome you all in the online session of our generation lecture. Hope you all are fine and having good health during the second wave of COVID-19. And if you have any kind of query till now in the previous session and today's session, please feel free to ask. I will answer your queries, your question. Otherwise, we start the next topic of thermal power plant, that is steam turbine. If you have any kind of query, please feel free to ask. Otherwise, I will continue the session. Hopefully, you not have any kind of query. So focus on the lecture. A steam turbine, that a dry and superheated steam from the superheater is fed to the turbine by means of main valve. Due to the striking or reaction impact of the steam on the blades of turbine, it starts rotating. As an example, heat energy is converted to the mechanical energy. After giving heat energy to the turbine, the steam is exhausted to, to a condenser, which condenses the exhausted steam by means of cooled water, that is we call evaporator, to the circulation. There is the enormous amount of the size you can see the wind turbine, the steam turbine, sorry, steam turbine. These are the blades of, you can see the person, looks a tiny as compared to the turbine and the person. So imagine how much enormous size the turbine you can see here. These blades are made by the titanium of blades. This is the steel rod, coupling rod, which is the common shaft from the starting of thermal power plant to rotate itself to couple with a generator with the coupling turbine, and furthermore at the end the generator is connected. This is the prime mover which can rotate the generator, and this is the shape of steam turbine. Okay, move on to the next slide. Alternator. This is the fourth part of thermal power plant or steam turbine, that a steam turbine is coupled to an alternator. The alternator converts the mechanical energy into electrical energy. We all know that at the end of thermal turbine, water turbine, and any kind of turbine, at the end level, the generator is connected. Generator is also known as the alternator, which can convert the mechanical energy into electrical energy. We all know that generator is a device which can convert mechanical energy into electrical energy, same as for alternator. So this is the kind of alternator is also installed in our electrical power lab. I think you all know. The electrical output is transferred to the bus bars through transformer, circuit breaker, and isolator. These are the things which are also used for the protection purposes and feeding the electricity to the transformer or transmission line or the main national grid. Feed water comes to the fifth part of this steam turbine. The condensed water produced in the condenser is used as feed water. The water which remains after the steam of rotating turbine, the particular water further feed to the feeding way for the cyclic process to make the water into again steam, wet steam, dry steam, superheated steam, and further in to the steam chamber. Some amount of water may be lost in this cycle, but it is compensated during an external source, and the cycle repeats and gives a better efficiency to the system. That means if you have the limitation of water, you have to particularly compensate or arrange the water. That's the reason we are installed the particular kind of nuclear power plant and thermal power plant in near to the river, दरिया के किनारे install करते हैं हम. That's the main thing. So I'm taking a small short break of 30 seconds. You can read this thing and ask if you have any kind of query. Students, if you have any kind of query till now, please feel free to ask. Uh, Further, we continue the next slide of the portion. After fifth section, we comes towards the cooling arrangement. In order to increase the efficiency of the plant, of power plant, we also can set the steam coming from the turbine is condensed using condenser. So if steam have to be condensed from the condenser, the water circulation for cooling steam in condenser is take from a natural source like river, steam, etc. And the outcoming hot water from condenser is discharged in some lower portion of the water source. So categorically, we need to arrange some kind of cool water and condenser to convert the particular hot water into a cool water and then further feed to the economizer to convert the liquid of water into steam. For that purpose, we need to arrange a cooling arrangement or cold water. In scarcity, in scarcity of water, the water from the condenser is cooled and reused with the help of cooling tower. So we need cooling towers. Anyone can see the cooling tower, that how can it be, how it can be like? Anyone of you can know what is cooling tower? No one know about this thing? Cooling tower. Anyone have idea about the cooling tower? Otherwise, I can explain you what are the cooling tower in thermal power plant. Up till now, if you have any kind of query, please feel free to ask. I will answer your all kind of question. My system is hanged due to some kind of reason. These are the cooling tower. Here you go. These are the cooling towers. You can see to cool the water and further provided to the economizer. This is the cooling tower. These are the cooling tower. This is a chimney. Cooling tower, cooling tower. These are the cooling towers. That hot water coming towards this way and it will be bombard. Bombard means बारिश होती है पानी की उसके बाद. That circulation of water can be flow from it. Water can be distributed in these showers. After these showers, water can be uh, going towards from exchange surface. That water can be, यहाँ से बहता हुआ पानी आता है फर्दर, जैसे रूम कूलर में आपने देखे चैम्बर्स लगे होते हैं, पानी ठंडा होकर निकलता है उसमें से गुजरता है. दैट्स द थिंग, that water can be going towards the exhaust exchange surface chambers and in the form of droplets. This is the same thing which I already see in steel mill during my internship. And after that, the water is collected at this level, that is basin, and cooled water can be extracted, that further provided to the economizer. Till now, if you have any kind of query, please feel free to ask. I will answer your questions, your query. If any person have any kind of query, please feel free to discuss. I will answer your kind of questions. Uh, Cooling arrangement and cooling tower up till now we have discussed, and I represented to you. Comes to that. Further, next section, steam turbine power plant, how it looks like. This is the way that steam is collected. These are the chambers on which the steam is collected, and further these are the way of collecting water. Steam turbine, sorry, these are the steam turbines in sections. These are the three sections of steam turbine. A common shaft is coupled. This is the primary section of turbine. These are the secondary sections, or these are the secondary chambers. At the common shaft is coupled from this way to the end of this generator. It is an alternator that converts the mechanical energy into electrical energy. Same thing for generator. At the end of this way, our work can be start. We can say the electrical energy can be produced, and then going towards the transformer, and transformer that step up that electricity and provide it to the national grid. Up till now, if anyone have any kind of query, please feel free to ask. Lignite fire, brown coal. Lignite fire means the name of coal. कोयले का नाम है lignite. In previous session we already discussed about the lignite coal type of fire. Brown coal. Brown coal is a type of कोयले की किस्म है ये, ठीक है. कत्थई कलर का होता है ये. Power plant, that is the burning fuel. This high output plant began its operation in summer 2000. Summer 2000 is the date in which season it was function. Its large steam turbine generator has an output of 906 megawatt. This is the largest generator which is installed in this plant. Designed for supercritical steam condition at 258 bar of pressure. This is the pressure of bar in bar, and it is the enormous pressure of steam that you can't imagine even. At the temperature of 541 degrees centigrade, this is the temperature of that particular steam, and we even can't imagine particularly. This is the temperature of superheated dry steam. It is the first to be equipped with 6 flow low pressure section. These are the subsections of 6. Further division into two parts. These are total 6 sections. Furthermore, coal-fired steam turbine. This is the coal-fired steam turbine. That means uh, steam can also be in it, but it is a coal-fired steam turbine. The turbine which is used in these sections, which are talking about, this is that coal-fired steam turbine. Siemens is planning the world's most efficient coal-fired power plant that is expected to operate at a steam temperature of 700 degrees centigrade. It is the enormous amount of temperature, even very drastical temperature. With an efficiency over 50%, the facility is being designed to produce 40% less carbon dioxide. This is the main the achievement of Siemens, that it can facilitate is being to produce 40% less carbon emission. That carbon dioxide is a carbon emission which can cause to damage the environment and its natural beauty, and it produce the chemical reactions for that cause to damage the environment and ozone layer. That's the main thing, that 40% less carbon production can be produced by the Siemens turbine, and this is the main and biggest achievement of this Siemens. Then the current international plans call the plant to go into service in 2014. This is the another way of look of steam turbine. As you can see, this is another look. These are the primary blade of steam turbine, and further section, these are the secondary blades in small in size. All are rotatory blades, and they play their particular role in the rotating the common shaft. Steam turbine, that is 123 megawatt. The whole turbine blade are made by titanium, and the shaft is made by steel, stainless steel. For the first commercial solar thermal power plant in the US, United States of America, using a power tower, steam is generated from water heated by thousands of mirror. Steam is generated from thousands of mirror. That particular heat is collect. The power plant will begin operation in late 2011, supplying power to 35,000 households. That means कि 35,000 घरों को बिजली फराहम करती है यह टरबाइन 2011 में. The facility in California's Mojave Desert is being built by Bright Source of Energy, and we all know that United States of America is the main country which produce electricity in the largest quantity of the world. Of the world. Of the world. So this is the main thing that US have many kind of projects in thermal power plant, and even I telling you that in previous session we also discussed that America, or United States of America we can say, is the first country who can produce the largest amount of electricity from its thermal power plant, steam turbine or coal based thermal power plant, and furnace oil based thermal power plant. And the largest quantity of power of electricity generation in the whole world was number one state was in USA, further in China and Australia and furthermore. But in number one state to produce electricity in the largest amount is America. And conventional way, America uses thermal power plant. So resources to burn the resources and replace electricity. This is the main feature to produce electricity by this way. Till now, if you have any kind of query, please feel free to discuss. This is the gas turbine. If you can see, these are the chambers: primary chamber, secondary chamber, sub-secondary chambers. This is the housing. This housing I can already seen in steel mill. That was the turbine. I thought 10 megawatt. That turbine was 10 megawatt, and it was installed in steel mill. These are the kind of turbine blades. These are the sections, subsections. This is the housing on which it packed, and you can see this thing. The STG 5 8000H gas turbine capacity. This is the serial number and capacity of 340 megawatt. The rating of turbine, the real power. The world most powerful gas turbine. Output equals that of 13 jumbo jet engines. Jumbo jet engines. That engines particularly installed in between the turbines and at the end of the turbine particularly. This is the primary jet turbo engine, and it is installed in between the turbine junctions. This unit will be expanded to become a combined cycle power plant. Combined cycle power plant is what in which heat and steam both are involved to produce the power plant. Okay, the combined cycle power plant with an output of 530 megawatt with an efficiency greater than the 60% compared to the average coal fired. Coal fired means जहाँ पे कोयला जलाया जाता है to burn the coal and produce electricity. But combined cycle power plant can produce electricity more than a conventional thermal power plant. This is the main thing, that the best way to use combined cycle power plant instead of the conventional power plant, that is conventional thermal power plant. That's the reason most of the developed country moving toward the technology of combined cycle power plant as compared to the conventional thermal power plant. uh, and we are Pakistan relying on the thermal power plant. We are not moving towards the combined cycle power plant because it is the latest technology power plant with the same output. This power plant emits approximately 2.8 million tons of less carbon dioxide per year. That means it is a best solution because it produces less amount of carbon emission in environment, and it is, we can say, it is an environment friendly project per year. Per year means it is big achievement even you we can't imagine, because in thermal power plant are too much dangerous for environment. It can toxic for birds, even also it can toxic for animals even, because the wastage of that particular industry was should be uh, damage the our animals, our species, special species that was in that should be in water. Particularly these species would be damaged due to these kind of things. And also this thermal power plant also affect the human lives even also, particularly ozone layer can also be damaged, and the ultraviolet radiations can be entered in earth environment. And due to this reason the toxic amount of environment can be produced, the skin disease can be produced, skin cancers kind of disease can be produced, and the greenhouse effect can be produced. That kind of thing we have to avoid thermal power plant. But due to these technology combined cycle power plant, the carbon emission is less as compared to the conventional thermal power plant. I think you all have understand the kind of thing which I explained to you till now. If you have any kind of query, please feel free to ask. I will answer your queries, your questions, your any kind of thing. And if you have anything that you have to add at this level, please speak. We all have to listen to you. If you have any kind of query, please feel free to discuss. Okay, as much as 1 million automobile emit. You can even in 1 year, automobile 1 million automobile that produce particularly 2.8 million tons of carbon emission. This kind of carbon emission was produced in the air by this combined cycle power plant of the gas turbine. Now, moving towards the next slide, that power plant fundamentals, economics, and administrative concepts. The particularly comes toward this thing introductory level. In all the field of industry, economics plays an important role in power plant engineering. Without economics, other thing cannot be make. Which means, if you, as an example, if you want to make a house for your family, you first have to arrange the financial assessments and finance, that how much the cost of house, how much the material can be installed. These are the we called economics. So if you plan to install something, you need to work on its economics even also. You need to understand the economics of power plant also. Being an electrical engineer, you need to understand the economics of power plant, and especially for thermal power plant. Because why? Because most of the thermal power plant installed in our country are based on the conventional thermal power plant. So we need to understand the economics of power plant. Even it is not particularly uh, for it is not particularly only for uh, thermal power plant, even for nuclear power plant even also. Even you can imagine the Canop Unit 3 can be installed near about the next year or next upcoming years. So the team of that particular economic team of the financial task force and further kind of forces are working on the economics of the thermal power plant and nuclear power plant which can be developed. And before the developing of the state, economics should be arranged for that, that who can provide the loan, particularly material, what is the cost of material, particularly what will be the rate of dollar at the time, because most of the thing can be imported from the outside the country. That's the thing we need to plan for the, and we need to work for the economics. Till now, if you have any kind of query, please feel free to discuss. Otherwise, we are coming towards the slide. Economics plays an important role in power plant engineering. Economics of power system use certain well-established techniques for choosing the most suitable system, where the power plant design must be made on the basis of most economical conditions and not on the most efficient conditions, as the profit is the main base. You all know that if you invest something, if you want to make a plant, if you make a want to make a university, if you want to make a coaching center, you need to invest first, and then after its operation working, you need to get its profit. So you are too much. keen interest in your profit after the investment. And we all understand the kind of thing, as the profit is the main base of the design of the plant, and its effectiveness is measured financially. So finance is the most important thing, in which your loans, in your investment, and your profit is also involved in financial things. The main purpose of design and operation of the plant is to bring the cost of energy produced to minimum. Among many factors, the efficiency of the plant is one of the factor that determines the energy cost. At the end, when you install a power plant from to get a loan from the international investment bank, and particularly different kinds of bank from the loan from banks, and particularly collect some amount of money from your countryside, and to invest some kind of amount to produce a thermal power plant. Financial cost, functional cost, maintenance cost, all the kind of cost can be involved at this level. And when electricity produce, you need to decide the tariff at this level. जैसे मिसाल के तौर पे मैं इसको इस तरह समझा सकता हूँ आपको कि इलेक्ट्रिसिटी अभी नए साल 1 जनवरी 2021 से महंगी हो गई है, तकरीबन 1 रुपये 6 पैसे महंगी हुई है। तो उसकी वजह ये है कि जो इकोनॉमिक्स होती हैं, उन लोगों ने ये चीज़ सोची है कि जो बिजली पैदा हो रही है, हम जो पैदावारी लागत से कोयला खरीद रहे हैं, फर्नेस ऑयल खरीद रहे हैं, या गैस हम फर्दर इंपोर्ट कर रहे हैं, तो इसको जलाने के में जो गो हमें कॉस्ट लगती है, ऑपरेशन कॉस्ट लगती है, उसके मुकाबले में जो हम फी यूनिट पैदा करते हैं, उसकी वजह से हमें बिजली जो हम सेल आउट करेंगे उसका मुनाफा कितना हमें मिलेगा, दैट व्हाट अ सिंगल यूनिट can provide a benefit to us. That's the main thing which involve in economics. Okay, comes to that. Till now, if you have any kind of query, please feel free to ask. I will answer your questions. Further, move on to the next topic. Before concentration on the economic factor, let's look into the principles of power plant design consideration. Properly selected location. First, you have to select at what location you have to install your that particular thermal power plant, nuclear power plant, wind power plant, solar power plant, and other kind of power plant. You first have to select the location. Particularly, simplicity of design should be simple and not too much complex. Cost, low capital cost, and it have consist of the low capital cost, low cost of energy generated, high efficiency. The plant which you want to install in the particular location, it should have to be in high efficiency. Low maintenance cost, low operation cost. These are the two factors which can cause a high kind of amount, because these are the maintenance operation cost are the uh, mandatory cost which can be used to maintain a power plant, that kind of thermal, kind of nuclear, kind of wind power plant. The maintenance operation cost must available there. Reliability of the supplying power, reverse capacity to meet future power demand. Sorry, reverse, it is not reverse, it is reserve capacity to meet future power demand. That means in previous some kind of months before the situation of COVID, or during the situation of COVID, we extend Tarbela extension, I think fifth extension or sixth extension. So there is a need of extension to extend power plant to increase it meet up capacity for future demands, because the population of country and the population of a state, further province, further country would be increased in near to the future. So we have to plan for it and to install more power plants. And if we not in the condition to install a new power plant, we have to extend our existing power plant in with the new units. As I provide you with example of Chishma power plant, Neelam, Jhelum, and Tarbela Dam, Mangla Dam. These there are some kind of extension would be produced into the future, and Tarbela Dam got its fifth extension or sixth extension in the situation of first COVID-19 wave. In between, I think. the year of 2020. Moving towards the next slide. Up till now, if you have any kind of query, please feel free to discuss. Okay, ji. Comes factors related to plant performance and demand variation. Number one is that load factor, capacity factor, utility factor, diversity factor. These are the main thing, and they have their own typical formulas. Availability factor, demand factor, plant use factor. These are the main features. Terms and definition: connected load is the combined continuous rating of all receiving apparatus on consumers premises which is connected to system or plant of the system under consideration. This is the connected load which is connected to the national grid, which is connected to the local grids or connected to the substation. These are the connected load. Demand and is the load expressed in kilowatt. Demand always in kilowatt. This is the real power. This is not apparent or a reactive power. Real power is your actual power which is consumed by the consumer. This is in kilowatt. Okay. That is drawn from the source of supply at the receiving terminals. Average over a suitable and specified interval of time. Comes to the maximum demand or peak load. Can anyone tell me what is maximum or peak, maximum demand or peak load? What is it? As reflected by its name. So can anyone tell me what is the, what do you understand by maximum demand or peak load? Yes, my friend, can anyone tell me what is the meaning of maximum demand or peak load? Uh, so that maximum demand is that this duration we are taking the class, the maximum demand or peak load will be feel during or after 6 p.m. to 10 p.m. or 11 p.m. In the time of Karachi, you can see the maximum peak time would be from 5 p.m. to 11 p.m. This is the main peak time at which the peak load observed by the power plant according to Karachi. But in conventional way, we are talking about the national grid. The peak time officially was 6 p.m. to 10 p.m. This is the main thing, uh, where the automatically the lights, conventional loads, and lightning load, heaters, and in winter era can be on particularly. Okay, comes to the description and definition. That maximum demand or peak load, what is it? Is the greatest of all the demand that have occurred during the given period. That means it is the greatest demand that a power plant or consumer can produce at the end of power plant. Power plant can be see this maximum peak at the level of 6 p.m. to 10 p.m. officially by the NEPRA or National Grid. Load curve. And what is load curve? Is the graph a graphic record showing the power demands for every instant during a certain time interval. This is the load curve, which can provide you a graphical view that how much load is used by a consumer. Up till now, if you have any kind of query, my friends, please feel free to ask. I will answer your kind of questions. And if you have not kind of query, then we moving towards the next slide. Now this is the formula of load factor. Load factor is defined as the ratio of average load demanded to the peak load demanded during a certain prescribed period of time. That means it is a ratio of average load demand over peak load demand. Average load demand over peak load demand is called load factor. And that particular load can be set in energy because our household energy can be consumed in kilowatt hour and it is a unit of energy Particularly, it's a unit of energy, kilowatt hour. Our bill or consumption of load can be made by the utility in kilowatt hour, and it is a unit of energy. That's the reason the formula of load factor can be utilized from this way to this way, that energy consumed during over maximum demand. This is the main formula of load factor. If anyone have any kind of query, please feel free to ask. Then we're going towards the next slide. Capacity factor. And what is capacity factor? It is actual output. First, we have to understand it by the definition. Capacity factor is defined as the ratio of actual output of power plant over a period of time to its output if it had operated at full rated capacity during the same period of time. That means the formula actual output during output that could be produced at the rated plant operation during. So this is your capacity factor. Furthermore, moving towards the capacity factor, these are the explained in better way. I already share the kind of slides with you. So by yourself, you can read this thing. And by the recorded session, I'm moving towards the next slide for reserve capacity and how it can be found and what is it. Reserve capacity, that is we called RC, is defined as the difference between the total rated capacity of all the units in the grid. That means the difference between the total rated capacity of all the unit in the grid, your local grid or national grid network, and the expected peak demand of the system. The plant reserve capacity can be approximated as in the following expression. That is, reserve capacity means the load factor, the load factor minus the capacity factor. Load factor minus capacity factor. The difference of this thing, we got reserve capacity, where normal values of reserve capacity usually maintain at about 20%. Up till now, if you have any kind of query, feel free to discuss. Otherwise, we move towards next slide. Capacity factor. Capacity factor we already discussed here. Capacity factor and load factor. These two formula we already discussed, and comes toward the reverse reserve capacity. Okay, ji. Comes towards the utility factor, that is UF, and how it can be defined, that the ratio of maximum demand of a plant to the rated capacity of the plant. So it's a ratio of utility factor, that maximum demand of the plant के maximum demand प्लांट कितनी सस्टेन कर सकता है, यानी वो चला सकता है मैक्सिमम डिमांड, एंड द रेटेड कैपेसिटी ऑफ द प्लांट, और उसकी रेटेड कैपेसिटी है क्या, जिसके ऊपर वो डिज़ाइन किया गया है, वो कितना दे सकता है या कितनी डिमांड बर्दाश्त कर सकता है, और उसकी ऑपरेशन कैपेसिटी कितनी है. रेटेड मीन्स ऑपरेशन. दैट रेशियो इज बी कॉल्ड यूटिलिटी फैक्टर. Or we can got the maximum demand. If we want to find the maximum demand, it having the formula maximum demand equal to maximum load multiplied by the load factor. If we multiply the load factor towards the maximum load, we got maximum demand. But the same formula, uh, utilization factor, if we want to find, so maximum demand, and how it can find maximum load minus load factor, we have load factor 0.80 and maximum demand, sorry, maximum load is 100. Multiplied each other, we got maximum demand, and divide by the rated capacity, that means that is 200. If suppose given these two things by the giving this numerical, these numerical are also are simple, but I skip these things which are discussing here. In topic 3, we are discussing about the utility factor. Comes toward this. Utility factor can be 0.40. By the multiply 100, we got its percentage. That means the utilization factor of or utility factor of the plant is 40%. If It have the rated capacity is 200 megawatt, and the maximum load it can be drive of 100 megawatt, and the load factor is 80%. By this specs we can find the utility factor in topic 3. Up till now we discuss fourth, diversity factor. It is also a main aspect. We are also discuss this thing in power distribution and utilization, because these are the utilization aspect. We already discussed these things in power distribution and utilization. Okay, diversity factor, that is DF. Maximum demand plus multiple maximum demand, multiple maximum demands, all plays in numerator, divided by the highest maximum demand among the group. That means the highest demand. These are the groups, and in which we extract the maximum demand, particularly at 11 a.m. or 6 p.m. or 5 p.m. Particular kind of demands can be got at this level, and over the maximum demand of the group, the highest maximum demand can place here, and divided by this thing we got the diversity factor at this level. Moving towards the fifth, availability factor. Coming towards the availability factor, it is known as the plant operating factor, and it is defined as the ratio of the time period in which the plant was in operation to the total time period considered. Coming towards the formula, that availability factor, time period the plant in operation over total time intervals. The ratio of this thing can be expressed in this example formula, that a running time in which the plant is running time plus time standby and stoppage time, all the kind of times can be adding, that is total interval of time or running time over divided by this thing, we got the availability factor. Coming towards the example, a plant is ready to operate during one particular week but held at standby. Availability factor, it got 1, and CF, that is capacity factor, is 0. Particularly, if the plant operate at half rated power for 1 month, is availability factor is 1, and CF it's 0.5. Today's This is the last topic of today's session, that is demand factor. And what is it? The ratio of the maximum real power consumed by a steam system to uh, that is called the maximum demand factor. The maximum real power that would be consumed if the entire load connected to the system were to be activated at the same time. Another way, in formula wise, we can explain this thing, the maximum demand of the consumer over the connected load, कि आपकी मैक्सिमम डिमांड कंज्यूमर कितनी कंज्यूम कर रहा है उसके मुकाबले में आपका कनेक्टेड लोड कितना है, कि लोड तो आपने इतना लगाया लेकिन आपकी डिमांड ज़्यादा है, तो उसका जो रेशियो होता है दैट वी कॉल्ड डिमांड फैक्टर. Up till now, we end today's session. If you have any kind of query, please feel free to ask. I will answer all the kind of query. And if you not have any kind of query, so we end today's session. uh, Allah Hafiz.